So by the time students get to fifth grade, we'll be using long division. If we use the most efficient products and leave off multiplying by tens, basically ignoring any placeholder zeros, then we really have the basic process for long division. So this also uses that division bar, and we will put the quotients on top, and we kind of fill in place values as we divide. So most children prefer scaffolding, but scaffolding doesn't work with decimals, right? So there are other ways to divide decimals than long division, which you should see in MAE 202. But this really is the most efficient way, efficient meaning fastest, right, to divide whole numbers and also decimals. So we're going to repeat all the previous examples, but doing this with long division. So this is a new method here. So the first one we did previously was 60 divided by 22. And so I'm setting this up the same way, right, with my long division bar, my quotient bar here. 60 is my dividend, 22 is my divisor. What I'm not going to do is I'm not going to put this bar along the side, right? So since I'm not doing scaffolding, I'm doing long division. All right, so what I would do here is I'm still thinking of, okay, how many times can I subtract 22 from 60? But I'm looking for the most efficient, right? So I can't just say, oh, well, let me subtract 22 once and then maybe I'll subtract it again later. This is going to be, how many times does it go in to where I can't subtract it anymore, right? So I'm going to have to find the most efficient answer. Now this one's not bad and we've already done it twice. So we know we subtracted 22 twice earlier, right? But you would, go off to the side, do some scratch work. So maybe do 2 times 22, see what you get. Do 3 times 22, see what you get. In this case, I think that should be too big. Or you take an educated guess. And that's kind of the method I like to take here, is I just take an educated guess. And if I guess wrong, it usually points me towards the correct answer pretty quickly. So I'm going to say I think 22 goes into 62 whole times. And then I'm going to write that above that. And this is less important with whole numbers, but you'll see when you get to 202 and you do decimals, it is best if you line this up above the 0, right? Because we're not saying 22 goes into 6. We're saying it goes into 60, right? Again, I don't think it'll make a difference here with whole numbers, but it will later with decimals. So then once you write a number on top, you are going to multiply that by your divisor, right? So 2 times 22. If you can do that in your head, great. If not, you can do that step by step, and sometimes that's going to make sense. So like 2 times this 2 would be 4, and then 2 times this 2 would be 4, right? So you can essentially distribute that or split it up just like we do with our multiplication standard algorithm. All right, so then once I write a number below that dividend, we're going to subtract. 60 minus 44 is 16. So how do I know if I picked correctly? You need to check, right? You need to check, did I pick the right number? Is 2 the correct number? So one thing you want to check for is when you multiplied, what you got here, was it smaller than the 60 that we're trying to subtract, right? So since 44 is smaller than 60, I know that I did not pick too big of a number, right? So like if I had tried 3 instead of 2, 3 times 22 is 66. So then this would have been a 66 instead of 44. That's bigger than 60. So that would tell me I went too big, right? I picked something too big. And then how do I know if I picked big enough, if it's not too small? You want to check and see your remainder. Is your remainder smaller than your divisor? So like if I had only done 1 here, my remainder would have ended up being what I think, what is that, 22, so that'd be 38, right? So I'd have 38, and that's bigger than 22, right? So if you get a remainder that's bigger than your divisor, you'd say, oh, wait a second, I didn't pick a big enough number, I need to redo that step. And so then here we would just, when we get down to this point, we'd say 22 doesn't go into that, so we would typically write it up here with the R. So we'd say this is 2 remainder 16. So then let's do the next one. The next one was 85 divided by 14. And we can typically try to do this a digit at a time. That does not always work. So what I mean is you can try and see, instead of 14 going into this whole dividend, you can see, will it just go into the first digit or the first two digits? So in this case, 14 doesn't go into 8. So I would have to go ahead and look at the whole number. And so I'm looking at how many times will 14 go into 85, right? And so, you're taking an educated guess. I'm thinking like 14's close to 15. I know 15 times 4 is 60, so it'd probably go in another time or two. So maybe 5 would be a good guess, maybe 6. And so we would just try it and see if it works. So just to show you like this process, I'm going to go ahead and I'll try 5. So let's say I think 14 goes into 85 5 times. I'm going to write that 5 up here, and then I'm going to multiply that. So I can do 5 times 4 is 20, and regroup my 2, and then do 5 times 1, which is 5, plus the 2 that I regrouped, so I get 70, right? So I know I did not pick anything too big, right? Because 70 is smaller than 85. However, if you subtract this, 85 minus 70, that's 15, right? That means that actually 14 would go into that again, and I'm not doing scaffolding, so I'm not gonna like just do that again. I'm gonna say, oh, I didn't pick the right thing, right? So since 14 goes into 15, this is too big of a remainder, which means I shouldn't have said this goes in 5 times. I should have said it goes in 6. But that's very normal, right? So like notice that, okay, yeah, we guessed wrong, but the wrong guess points you to the right answer. We saw, oh, you got 15 left. That means it's going to go in just one more time. So we erase and we try it again. So then let's do 6. So 6 times 4 is 24. 6 times 1 is 6, plus 2 is 8. And then we subtract and we get a remainder of 1. So that one, I know that I picked correctly because 84 is smaller than 85 and 1 is smaller than 14, right? So we're comparing this number to the dividend, right? The 84 to the dividend, and we're comparing this number, the remainder, to the divisor, right? And so in this case, my answer would be 6 with a remainder of 1. The next one was 97 divided by 15. All right, so how many times does 15 go into 97? I know 15 times 10 is 150, so that's way too big, right? So maybe roughly half of that, like maybe 5 times, maybe 6. I'll go ahead and I'll try 6 and see if that works. So let's see, 6 times 5 is 30. And 6 times 1 is 6, plus 3 is 90. So I did not pick too big because 90 is smaller than 97. When I subtract, how do I know if I picked correctly? Well, I can see 15 will not go into 7. So that's what I want, right? If 15 would have gone into that, I would have known that I needed to pick a bigger number. So in this case, my answer is 6 with a remainder of 7. Let's take a look at the next one. So this one is 582 divided by 18. This one's a good example of what I was talking about of doing a digit at a time. So I do not have to look at this and try and figure out how many times 18 goes into 582, which is good, right? Because that's a lot of times, right? So I don't have to do that. I can look at this a digit at a time, look at my dividend and say, will 18 go into 5? No, it doesn't go into 5. So then let me look at the first two digits then. Will 18 go into 58? Yes, it will, right? So I don't have to figure out 18 into 582. I can just, for right now, do 18 into 58 and use my place values here. So how many times will 18 go into 58? I'm going to guess 3, just because I know 18 is close to 20 and 20 times 3 is 60. So I'm going to try 3, and notice I put my 3 above the 8, right? Since it goes into 58, not into 582. So then let's do the multiplication. 3 times 8 is 24. 3 times 1 is 3, plus 2 is 5. So I did not pick too big because that's smaller than 58. If I subtract 58 minus 54, I get a remainder of 4. So I did not pick too small either because 18 won't go into 4. But I'm not done, right? So this was my first step. There's still more to this number. I still have the 2 here. So some people say to bring down just the next digit. Some people bring the whole thing down. If you bring the whole thing down, I tend to do it that way. But if you bring the whole thing down, just make sure you just look at just the next digit, right? Here, the whole thing is just 1 digit. So now I'm going to do this whole process again. I'm going to say, okay, now I want to see how many times will 18 go into 42. So again, I'm just taking educated guesses here, but since I know 18 times 3 was 54, it's not going to be that big. So I'm going to try 2. 2 times 8 is 16. 2 times 1 is 2, plus the 1 is 3. So that looks good so far. And then if I subtract that, I get a remainder of 6, and 18 won't go into 6. So this means my answer here is 32 with a remainder of 6. Our next one is 2,670 divided by 23. Let's look at this a digit at a time on my dividend. 23 will not go into 2. So then let's look at the first 2 digits. And if that doesn't work, I'll look at the first 3. Will 23 go into 26? It does. It goes in 1 time. So I'm going to write that above the 6. 1 times 23 is 23. And I'll subtract to get my remainder of 3. So I picked correctly because 23 is smaller than 26, but 23 is bigger than 3. All right, so then I'm going to bring the rest of this down. And so this is what I was talking about, is some people will just bring down the next digit. I tend to go ahead and bring down all of it. But again, I don't have to look at this whole thing. I can just look at this a digit at a time and say, well, 23 goes into 37. Pretty sure it just goes in once again. So 1 times 23 is 23. And if I subtract that, I get a remainder of 14. And now let me bring down my 0. And now, since 23 doesn't go into 14, now I would look at all 3 digits here and say, okay, how many times does 23 go into 140? Let's see, 23 times 10 would be 230. Half of that would be 115. So I'm thinking like either 5 or 6 times. I'm going to try 6. If that doesn't work, I'll be able to tell real quickly. 6 times 3 is 18. 6 times 2 is 12, plus 1 is 13. So actually that was the correct one because that's smaller than 140 and the remainder is smaller than 23. So my answer here is 116, remainder 2. So then let's do the last one, 94,651 divided by 52. 52 will not go into 9, but it will go into 94. Does it go in 2 times? No, 52 times 2 is 104. So that's only going to go in 1 time. So 1 times 52 is 52, and I'm going to subtract to get 42, and then I'm going to bring the rest of this down. So then let's repeat the process. So now I'm saying, okay, 52 doesn't go into 42. Does it go into 426? It does. So that's a fun one. I'm going to say that goes in 8 times. And I'm just thinking like 8 times 50. So I'm thinking that should work. Hopefully that's right. Let's see. 8 times 2 is 16. 8 times 5 is 40, plus 1 is 41. So yes, that does work. So this gives me a remainder of 10. And then let's bring the rest down. So then 52 into, I don't have to do 1051, I could just do 105, right? So 52 goes into 105, I think 2 times. So 2 times 52 is 104. So 105 minus 104 is 1, but then I need to bring this 1 down. All right, so now I've got 52, and I'm trying to see if that will go into 11, and it doesn't. So this is where you have to be careful though, right? Because that 1 is something that got brought down, right? So this is not just the leftover when I subtracted, that's the leftover plus the 1 that got brought down. So really what we're saying here is there should be a placeholder 0. Or you can also think of this as saying, how many times does 52 go into 11? It goes in 0 times, right? And that is one thing that can trip you up on long division, is those zeros that you sometimes need to put in, right? So 0 times 52 is 0, and then that would give you the remainder of 11. But basically, since there wasn't anything above the 1, and this is another reason why I like to line up my digits, that means there had to be a placeholder 0. So this is 1,820, and the remainder is 11.